Hi, in this video we are going to talk about the queue interface. So as we have discussed in the theoretical section, queue extends the collection interface, which extends the iterable interface. So queue is a collection as well as it is an iterable. And basically linked list, priority queue and array deck are the concrete implementations of the queue interface. In this video, we are going to focus on the linked list implementation of the queue interface, but what's very important that for a queue, we insert the items at the end of the queue and items are removed from the beginning of the queue. So it has a so-called FIFO structure, the first in, first out, which means that the first item we insert into the queue is going to be the first item we take out. We have been considering stacks and we have come to the conclusion that we insert items and we get items from the same direction. So we keep pushing items from here and we keep getting items from here. For a queue, we have a queue here, we insert items here, but we keep getting items from the other side of the queue. So that's the main difference between queue and stack. And as we have discussed that linked list and priority queue are the implementations of the queue interface, we are going to talk about priority queues in the coming videos, but basically it stores items internally according to their natural order. So we have to define some comparable that what's going to be the priority as far as the priority queue is concerned. We have several methods for the queue interface such as add. This is how we add items to our queue. We have the element. It's approximately the same as we have seen the peek method for the stack. So we get the first item without removing the concrete item. And we have the remove. This remove is going to remove the element at the head of the queue. So when we add items, we keep adding items from this direction. When we remove, this remove method is going to take items from this direction of the queue. And what are the applications? As we have discussed for stacks, we are able to implement the depth-first search, one of the famous graph traversal algorithms. For queue, we are able to implement the other important graph traversal algorithm, the so-called breadth-first search. And breadth-first search is the basics of other complex graph algorithms such as maximum flow algorithms, bipartite matching algorithms, and so on. So breadth-first search is quite an important algorithm, and the queue is an underlying data structure. By the way, it's not a data structure, it is an abstract data type, but whatever, it doesn't matter, which means that in Java, this queue is an interface. So let's see a concrete example. I'm going to have a queue. For example, it's going to store strings. It is generic, of course. And I'm going to implement it as a linked list. So java.util.linked list. And of course, we have to import the java.util.queue interface. And basically, it's going to work fine. I'm going to add a string, for example, Adam. I'm going to add some other names such as Joe and Kevin. We are able to iterate through with the help of a for each loop. String s and in the queue, and we are just going to print out the s. Because this queue is a collection and the collection is an iterable, that's why we are able to use the for each loop without any difficulty. If we run it as a Java application, it's going to get the order in which we have inserted. So we just iterate through the collection. But if we, for example, take the items, so I would like to print out if we call the queue.remove. We keep adding items from that direction. So Adam is going to be the first one in the queue, then Joe, then Kevin. If we remove, then we take items from this direction. So basically the first item we have inserted is going to be the first item we take out. So we are going to end up with Adam. Okay, And if we keep removing more items, then we are able to get Joe and Kevin as well. So I'm going to save it and going to run it, and as you can see, Adam, Joe and Kevin is going to be removed because the first item we insert is going to be the first item we take out, and we have inserted Adam first, then Joe, then Kevin. So that's why it's going to be the order. If you may recall stacks, if we insert 10, 20 and 30 and we keep popping the item, then 30, 20 and 10 was the order. It is quite on the contrary. It has a FIFO structure, and that's why the order will be Adam, Joe and Kevin. And we are able to use, I'm going to comment it out, we are able to use the element method. This element method is going to get the first item without removing it. So Adam is going to be returned, but if I system out println the q.size, the size is going to be 3. Okay, if I call the remove method, then the size is going to be 2 because we have removed Adam. So that's the difference between element and remove, that remove is going to remove the item from the queue, element is going to return the item from the queue without removing it. So that's all about the queue and the linked list implementation. Thanks for watching.